Hi, everybody. Thank you for joining. Today, we have Dr. Shwartz with us. She finished her PhD at the Bar Ilan University. She was a postdoc researcher at the Allen Institute for AI and the Poe G. Allen School of Computer Science and Engineering at the University of Washington. She is currently an assistant professor of computer science at the University of British Columbia. And in October last year, she was appointed as Canada's CIFR AI chair at the Vector Institute. Today's topic is going to be reality check, natural language processing in the era of large language models. And yes, the stage is yours. Thank you so much for coming.
Thanks for inviting me, and thanks everyone for joining.
And you can share. I'm going to unshare now.
Yeah. Okay. Yeah. Okay. I'll start with the necessary introduction, even though it's probably obvious for most people in the audience. But large language models solved, or quote unquote, solved many tasks that deemed impossible until recently. Compared to just a few years ago, these models have made a huge progress, both in terms of understanding queries in natural language or commands or questions, and also in terms of generating outputs that are coherent, relevant, grammatical, almost human-like, or human-like. And so here's an example. Again, I'm sure you've all played with ChatGPT, and so you know what it looks like. But in this example, I just asked it to demonstrate how good it is at understanding complex natural language queries and generating coherent human-like text. And so it generated the following. Let's see if, oops. Okay, it's a bit slow. Yeah, it generated the following. It, for some reason, decided to talk about dark matter. And I have no idea. I don't know anything about dark matter, so I can't really verify the correctness, but it is definitely coherent, and it looks pretty comprehensive. So these language models like ChatGPT became a product that is used by millions around the world, and people use it for different purposes, like getting advice on different topics, writing essays, getting help with writing, troubleshooting, and writing code, and many more purposes. So now that we have models that are good at representing and generating text, we can take one of the two approaches. The first approach, which was unfortunately taken by one of my recent grant proposal reviewers, is to declare that NLP is solved and that we should stop working on it. And the second, which is the approach that I'm taking, and I guess most NLP or all NLP researchers are taking, is that on the one hand, we can look for new opportunities that large language models created to work on tasks that we simply couldn't do before. While on the other hand, to do reality check regarding the remaining challenges, which may or may not be addressed with large language models in the future. And you could see here that even ChatGPT agrees with me that it did not solve NLP. So I'll mostly be focusing on the challenges part. And I'll start with talking about the fact that human language is often grounded in non-linguistic context, as opposed to language models, which by and large are only trained on language. I will then talk about advanced reasoning, which is an area that is still underexplored, but might be a good direction to work on now that large language models have made some progress on reasoning. Next, I will discuss the difficulties in applying large language models to real-world applications. And I will ask you if you have questions after each one of these parts. And then if we have time, we'll get to the last part, which is the short part, just about how, just mentioning a few problems with the current way that we evaluate the quality of NLP models. So let's start with grounding. So according to this maxim from linguistics, people don't state the obvious. Language is efficient. So We try to be as informative as possible and give just as much information as is needed and not more. So, for example, in this picture, she's telling him we're having coffee now, even though he knows they're having coffee now. So that makes it a bit funny because it goes against this maxim. As a result, a lot of situational context is actually missing from the text. Like, for example, the things that we see around us or the things that we hear, where we are, what the time is, what we do, like in this example, or other things like shared background knowledge or common sense knowledge between the listener and the speaker, and then also more specifically social norms and cultural norms. So I will mention three of these: the vision, word knowledge or common sense knowledge, and cultural norms. Even though in the past I've also worked on social norms and time. So let's start with the vision part. So because we don't tend to describe what we see to other people who see the same thing, very often vision and language provide complementary information. And I want to discuss this work that we just put on archive a few days ago. This is about meme interpretation. So in this project, my student Onjong and I, we looked at memes like this one. So in this meme, you have the text that says, "What time did you go to bed last night?" Me, early, why? And the title at the top is the title of the post where this meme was posted. So it's every damn time. And then people interpret this meme as follows. So they think that the person who posted the meme wanted to say that they lied about going to bed early and that they look horrible after not sleeping right the night before. Then a vision language model, which I will describe in the next slide, generated the following interpretations. Either that the meme poster wanted to say that they're tired but have to go to work, which is not exactly correct. That they don't remember. So yeah, these are actually three different setups. So the first one is just based on the meme alone without the title. You can see that it clearly focuses on the text inside the meme, but it's wrong. The second one, that they don't remember what they did the day before. This is actually based on the meme and the title, which is the most fair setup. This is the same inputs that people have, but again, it's wrong. And the third one, that they are scared of the monster. This is based on the meme, the title, and also an image, a literal image caption that we provided. In this case, it was a scary-looking monster. So it clearly focuses on the visual or the literal caption, which is wrong in this case. So we defined this new task, and then we collected a data set for it. And the first step of the data set collection was that we scraped memes from Reddit. Specifically, we were using r/memes, and we manually filter them to avoid duplicates or incomprehensible memes and all kinds of offensive content. Then we collected the literal image captions. So for example, for this meme, the caption would be something like, "The worst intersection in the world has to be controlled by a tree of traffic lights." This is an actual caption that we collected. And in order to not bias the annotators towards the metaphorical interpretation of the meme, we did not show them the post title, and we removed any text that appeared inside the meme by using like an image repair tool, like using OCR to recognize the text, and then using an image repair tool to complete what was supposed to be behind the text. And then in the third step, we collected the meme caption, which is more like the metaphorical interpretation of the meme. And so we showed a different set of annotators, the full meme, including the text in this case that says, "Hair, why doesn't he understand my signals?" The signals. The title that says, "Why they gotta be like this?" And also the literal image caption. And we first asked them to decide for each phrase in the image caption, whether it is used literally or metaphorically in the meaning of the meme. So, and then if it's used metaphorically, we also asked them to interpret the metaphor. So for example, they might say that an intersection is a metaphor for the relationship between a man and a woman, while a tree of traffic lights is the woman's complicated signals. Finally, putting all of these together, we asked them to write the meme description that uses the metaphorical rather than the literal meaning. So we get something like, women wonder why men don't understand their signals when they're overly complicated. We collected around 6,000 examples. Most of them are used for training, around 600 for each of the development and test set. So here's another model that we, this is one model that we developed for the data set. This is one of the baselines. It's based on Open Flamingo, which is the open version of Flamingo, which is a vision and language model. This is an example for the few-shot model, so it gets K-labeled examples, either 4, 8, or 12. As part of the input, and then the examples contain the title and the caption in this particular example, and then the target example from the test set contains just the title and the meme, and the model is tasked with generating the meme caption. So this is what the model generated for this example. The meme poster is trying to convey that they're annoyed by the traffic lights. So it's incorrect. We also trained many additional models with different setups like zero shot, few shot, fine tuning, chain of thought prompting, using different vision and language models. We also had mini and GPT-4 and different inputs like the meme, the meme and the title, the meme title and caption, and more, some ablations to show that both modalities matter in this setup. So we have many more or some more results in the paper, but this is the results from the human evaluation. So we tested the models that seem to be the best performing on, we tested most of the models with the human evaluation, and we asked people to evaluate the generated captions for correctness, whether they cover all the important visual and text elements, and whether they're faithful or they just make up things. So these are the results for the best model of each type. Summarized here, there's more detailed results in the paper. And so you can see that they are excuse me. You can see that they are far from human performance. And in particular, many of these models, they either just repeat the text that is already inside the meme, or they refer to the metaphorical elements in the image literally. Okay, so I'll think I'll pause for a question in the end of this segment. I'll move on to the next grounding example, which is common sense knowledge. So again, because of the same phenomenon in language, that we don't repeat the things that we assume the listener already knows, common sense knowledge in particular is rarely specified in language. And we actually employ our common sense knowledge to understand language. So do models do the same? So this is an ambiguous headline, and I've been using it a lot lately. I'm getting a bit tired of it, but I'm gonna use it until models get it consistently right. So this is a headline from a few years ago that says that Stevie Wonder announces he'll be having kidney surgery during London concert. So we know, so this sentence is ambiguous, but we know that the announcement happened during the concert, but the surgery happened sometime later, because we have this common sense knowledge that a kidney surgery is performed under general anesthesia, which means that the person undergoing the surgery will be unconscious and therefore unable to perform. And so in the past, I asked Unified QA, which is a state-of-the-art QA model at the time, when is the surgery, and it incorrectly told me that the surgery happened during the concert. Now, ChatGPT is a lot more careful. So in the first try, it declined to answer the question, and it said that it doesn't have access to recent events because it was trained on events up to 2021, and it doesn't have access to the internet, although this specific example is from 2019. So I changed a little bit, and then I presented it as a story about an anonymous performer, and then it said that the surgery will happen during the concert. So what if we had a model that can generate these common sense inferences about events that people make implicitly? Could we maybe help the model understand the story better? So we have such a model. This is the Comet model from AI2 that was released a few years ago. It's a large, or it's a language model fine-tuned on a common sense knowledge base that can generate all kinds of inferences about events. For example, if we put this input this title, it tells us that, for example, that before this event, he needed to go to the hospital, and and after this event, he performs at the concert and he goes to the hospital. And there are also two incorrect inferences here, like, for example, that the effect is that he has to cancel the concert, and which is incorrect because he doesn't actually cancel the concert. He attends the concert and announces that during the concert. And the second one is the hindrance inference, which says that something that would prevent this from happening is if he didn't want to ruin the concert, but merely announcing the surgery doesn't actually ruin the concert. And so the reason this happens is because Comet was trained on very simple sentences that only contain a single event. And what happens here is that Comet confuses these two events of the announcement and the surgery. So we recently developed a new model that can get a natural complex sentence with multiple events, like having and announces, and a target event, and then generate inferences along the same dimensions as Comet, but for each event separately, while taking the entire context into account. So, for example, for the announcement event, it generated that what would prevent that would be if Stevie Wonder does not attend the concert, and that before that, he thanked the fans for coming to the concert, and after that, he prepares for the surgery. It also generated an incorrect inference here that says that the effect of the announcement is that he recovers from the surgery. And then for the having event, it predicts that the effect is that he would recover from the surgery, and before that, he's rushed to the hospital. Now, not all of these are necessarily correct, but they're all supposed to be plausible. This is, again, from another paper that we uploaded to arXiv in the last few days. This is called Comet M. It was developed by my student, Sahitya. Notably, I tried to incorporate these inferences into ChatGPT and ask it again about the time of the concert. Unfortunately, it still couldn't get it consistently correct. And about half of the time, it still predicted that the surgery is during the concert. But I believe that would be the way forward, to just elaborate on these implicit inferences. So a little bit about this model, this multi-event Comet model. It's an extension of the existing Comet model to multiple events. And the way we trained it was that we first collected annotations for these 6 event-centric relations for over 1,000 sentences in different genres, like dialogue, news, fiction, and more. Overall, we collected about 35,000 inferences. And we continued training the BART-based Comet model on our data. And the reason for that is because this model has been trained on like 1 million common sense or event-centric common sense inferences. So we do want the knowledge it already has. We just wanted to adapt it to multiple events. So again, the paper has multiple different results. This one is for the human evaluation. And we asked people about the generated inferences about how likely or plausible they are, how specific they are to the target event, and how relevant they are to the entire context. And so you could see that Comet M outperforms both the using Comet directly and also Comet NLI, which is one of our baselines. Specifically, this baseline was trained with the same setup as Comet M, but on silver standard inferences that we generated automatically. So the way we generated them was that we break the complex sentence into multiple simple sentences using semantic role labeling. And so we get a sentence like Stevie Wonder has kidney surgery. And then we use the original Comet model to generate inferences for each sentence separately. That will be for the target event in that sentence. But then you might get inferences that contradict the entire context. Like, for example, maybe one of the inferences will be that he cancels the concert for that. And so we use a pre-trained NLI model to filter out the contradicting the inferences that contradict the entire context. And then, as I said, we just train it the same way as we trained Comet M. So you can see that it performs better than the just using Comet directly, but it still performs worse than Comet M. So having gold standard annotations was important here. And this is the last part for the grounding part. And so here I want to talk about cultural norms, and this is going to be about the observation, which is pretty trivial, I guess, is that prior experience and norms differ by culture. And I have this example here. It's a bit long, so I'm just going to tell you the gist. So I told ChatGPT the story about this couple that had a dinner in a restaurant in Spain, and they tipped 4%. And I asked the model what it says about them. And then ChatGPT said that they're either frugal, on a tight budget, or they didn't like the service. So
this is 3.5, right? Not the 4.
Not 4, yeah.
Okay.
So this is a very North American lens. And in fact, in Spain, tipping is optional and it's not very common. And when I add this information, it actually updates the generation, and it says that it correctly says that leaving the tip means that they enjoy the service and that they are kind. So it's not surprising because it's a language model trained on English text from the web, which most of it comes from the US, but it is something we need to take into account. And here's another example. This one is using Comet. And this is an example from my student Mehar. She's working on this project. It started as a course project with 2 other students in my class. And so they put the following sentence: person X eats a Dutch baby. And I guess, like, yeah, it's a talk in Germany, so I don't need to explain what a Dutch baby is. But Comet doesn't know what it is, and it interprets that literally and not as a pancake. And so it predicts that person X is seen as greedy, disgusting, mean, and starving. Other people, as a result, would feel guilty. The person X would feel guilty as a result, and will want to throw up, and that others, as a result, will feel sad and disgusting and angry. But if you just tell it that person X eats a German pancake, then all the inferences become either positive or neutral, and it just says that as a result, their person X is satisfied and full, etc. So in this project led by Mehar, where we use a database of cultural common sense knowledge called Kendall to enhance comment. This data set includes sentences like, for example, tofu is a major ingredient in many East Asian cuisines. So what we do is we first train BART, which is the underlying language model for comment, on statements from this data set, and then we train it again on the original comment data set. This is still work in progress, but we plan to evaluate it on GD VCR, that's Geodiverse Visual Common Sense Reasoning. It's a visual question answering data set that involves cultural knowledge, and we plan to show that if you provide this model with the GD comment that we develop, it's going to be better than, to provide it with information from GD comment. It would perform better than if you provided information from comment directly or no external knowledge at all. I'll be happy to answer any questions about that part before I move on to the second part.
Thank you. Can you go back to the second part about comment? And you talked about where you pre-trained it on NLI, or you said you used the pre-trained NLI model?
That was for the baseline. Yeah. So for the baseline, we want to train it the same way as Comet M. So we take the pre-trained Comet model and we continue training it on our data, except that instead of using our gold standard data like we do for Comet M, we automatically generate silver standard inferences by splitting the complex sentence into multiple simple sentences that each has one target event, or each one has one event. And then we filter out the contradicting inferences using an NLI model. So we look at the entailment relation between the complex sentence and each inference. And if it's contradicting, we just exclude that inference, and then we train the model on the silver standard inferences.
Thanks. I think, okay, I see a question in chat. So a bit of general question. Could you recommend any good resources for someone who wanted to get up to speed on NLP reasoning, common sense, and neurosymbolic AI? The goal would be to understand the current state of the art and what resources are available for academic research.
I actually don't know of it. Like I haven't checked any of the recent ones because this field is moving so quickly that it's actually kind of hard. I mean, I guess there is some summary out there, but it just moves so quickly. I guess my best suggestion would be to just follow the latest paper on the ACL ontology and to try to summarize that. But actually, if anyone in the audience knows of up-to-date good resources, if you could post it here, I would actually like to know as well, so that I can answer other people that ask the same question. We had a tutorial about common sense reasoning 3 years ago at ACL, and it's just so out of date at this moment because the field is moving really quickly.
I don't see any more questions in chat. I think we can move on. If anyone has any questions, put them in chat. We're going to ask them in chronological order.
Sound good. Okay. So the next thing I want to discuss is reasoning. So large language models have made some progress on this front as well. And one way in which language models could be used pretty successfully to answer questions that require reasoning is through the chain of thought prompting approach. So in this approach, so this works in the in-context or few-shot learning setup, but instead of providing the model with just a few examples of question-answer pairs, you also provide, the answer is also more elaborate, and it shows the reasoning that led to the final answer. Like, for example, here there's some math question. And in the standard prompting, the answer would just be the answer is 11, whereas in the chain of thought prompting approach, it would be Roger started with 5 balls, 2 cans of 3 tennis balls each is 6 tennis balls, 5 plus 6 equals 11, so the answer is 11. And so this works quite well. It has been shown to improve the performance on this task, and it looks like it's increasingly explainability as well, even though there has been some debate on whether the reasoning is faithful or not. And because the language models, they generate the answer following, like, right after the reasoning, but it's not explicitly guaranteed or even encouraged to for the answer to causally depend on the reasoning. And there was also follow-up work that tried to make it a little bit more faithful by doing this iteratively, like generating one step of reasoning at the time. I'm not going to get into the detail. And so we recently used chain of thought prompting for stance detection. So in this task, and this is unfortunately not yet publicly available. So in this task, given a tweet like she can't even manage her husband and she wants to be the president of the United States. This is in the context of the 2016 US elections. And a certain target, like in this case, Hillary Clinton. The goal is to determine whether the tweet is in favor of, against, or is neutral with respect to the target. So this task is difficult for multiple reasons. One of them is because the target is sometimes implicit, as in this example. She's not even mentioned in the tweet. The second one is there's a lot of ambiguity and reliance on prior knowledge and more. In addition, this specific data set that we use, that I forgot its name, but this specific data set for stance detection on Twitter, is the setup is actually out of the main evaluation. So even if you have a supervised model, it's supervised on one topic, and then it is evaluated on a different topic. So we showed that with chain of thought prompting, we can get state-of-the-art performance with a substantial gap from the other models, including the supervised ones. And the reasoning that we provide is this, like, one intermediate step. Like in this case, it would be that Hillary Clinton is not qualified to be president because of her bad managing abilities, and so that means that the author is against Hillary Clinton. But part of the problem with this task is that it's very rigid as a classification task. And in fact, we've had problem getting people to annotate examples because they say, I don't know, I don't have enough information to determine the stance. And so this is just an example of one of the tweets in the data set. When women spend too much time out of the kitchen, they get over-opinionated and think they know everything. #feminist. So on the face of it, this seems very much against the feminist movement. But what if I told you that this tweet was written by a feminist user as a sarcastic response to someone's misogynistic tweet? So what I think this task should be, the way that I think this task should be modeled in the future is that it's not going to be a classification task, but instead it's going to be more like a generative task where the goal is to spot these ambiguities and generate an answer that supports various different interpretations. Like in this case, we want to say something like this, the tweet seems to be against the feminist movement. However, there's not enough information to determine this with certainty. For example, if this tweet was written by a known feminist user, they might be using sarcasm to respond to someone else's misogynistic tweet. In that case, the user is actually in favor of the feminist movement. And that's actually very similar to defeasible inference, which is something that I worked on a few years ago with colleagues at AI2. So at the time, we created a data set for defeasible inference in natural language in multiple domains. So the goal here was that there's a certain premise, like for example, a group of people sitting around a table with laptops, and there's a hypothesis which may or may not be true, like they have a work meeting, and the goal was to generate an update sentence that is that either weakens the hypothesis or makes it less likely, or strengthen the hypothesis or makes it more likely. So for example, they're in a conference room, strengthens the hypothesis because you have work meetings at a conference room, but they're in a library, weakens it because you need to talk at work meetings, and in the library, you usually need to be quiet. So we had multiple domains. There was some work on that, but not a lot of it. This task is still underexplored. It seems that everyone prefers to work on deductive reasoning. But I think it's a good direction for something to work on in the future or now. One example of an application would be the stance detection example. Here's another one. So let's say that you're working on real-time summarization of some unfolding news event, like in the beginning of COVID, for example. There were these long articles in various different online newspapers, and they kept getting updated, and usually you would have this short summary at the top. But sometimes the conclusions that may have been included in previous summaries are no longer correct because we have new information. So for example, in the beginning, they thought that the virus could only spread from animals directly. And then later on, there was evidence that people can spread it to each other as well. And so if the previous conclusion appeared in the summary, that you would have to actually remove that from the summary. And so one way to do that would be with the feasible reasoning, and maybe coming up with this conclusion is true unless something else. It might actually also help the not just the summary, but the way that people think of all the options and study a topic. Is there any question about this part before I move on to the third one?
While we're waiting for question, I want to abuse the microphone. I want to ask something. This is kind of brainstormy. I haven't given it any thought because I didn't see this example before, but in this sarcastic tweet, the hashtag feminist tweet, just a brainstorming idea is, what if we do some kind of a GAN and try to, because humor is a very tricky subject, very, very tricky. And this is something that I don't think language models are going to be actually able to capture humor anytime soon, like real human humor. Even if we train them on 10 billion memes or something. But what I really think, maybe we can do some kind of a GAN and feed it like very, very subtle differences to see how it performs.
I think that's a really interesting idea, and in general, this direction of working on humor, I think that's a fascinating topic, and I agree with you. It's probably not something that's going to be solved soon, and probably not something that is going to be solved just with scale. I think it requires a lot of common sense, understanding how people interact with each other, understanding or having knowledge about the world, and yeah, it's I think it would be a really nice direction. I would love to see a paper targeting this task.
So we do have questions. Alina is asking, in the chain of thought prompting, do you think the model response would be influenced if the prompt included an error? For example, giving the model Mary has 6 apples, she gives 2 away. 6 minus 2 is 3. Therefore, she has 3 left, which is wrong. Which is obviously wrong mathematically, but the chain of thought aspect is still here. So do you think this type of thing would influence the model's response?
Yeah, and that's an excellent question. I would actually really love to see a paper about that. I think that these models get really easily convinced of errors. I've seen an example that it wasn't like chain of thought prompting, it was just like a single example from ChatGPT, that someone asked it, how much is I think it was something how much is like 51 minus 3, and it said 48, And then the user said, oh, my wife says it's 47. I don't remember the exact numbers. And then ChatGPT says, oh, I apologize, your wife is right. 51 minus 3 is 47. And so I think it would definitely confuse it. So I have seen another paper, I haven't read it yet, but there was something on Twitter a few days ago that showed that exactly the thing I was mentioning earlier, that chain of thought prompting is not faithful. But I don't know if they did that experiment in particular. And I think that would make an excellent short paper. I think you should write it very quickly for the NLP deadline.
I am taking notes the whole time.
Yeah.
Philip is asking, do you think the transformer architecture is sufficient to model all these abstract structures for reasoning, for example?
I've never been never put too much like hopes or like, I don't know, weight into the specific architecture. I think that the transformer architecture was mostly successful because it's more efficient to train than like the RNNs with attention. So you could train it on more data. I think it's mostly the scale and the data that makes it very successful. And so I don't know if the problem is the architecture. I think the problem is more about the training objective. So yeah, we do see some progress that there are other objectives now, like the reinforcement learning from human feedback and training on instructions and things like that, that make it a bit more successful than just a model that was trained on with language modeling objective. But I still think I don't know if all these problems that I'm presenting here would be solved with just like slightly different training objectives or more data or the right data. Some of these problems are like inherently difficult, but I'm also I don't like to make predictions because they're often wrong. Like one of the examples that I'm giving in another talk where I talk about ChatGPT is the movie Her from 10 years ago, I think. And I remember like watching that movie and I was like actually upset. I was like, this is so unrealistic. We're never going to have an NLP model that can talk like a human. And I was wrong about that. We do have something that talks like a woman, like a human, not like it doesn't think like a human and doesn't understand everything, but it does look very human. Like the text looks very human-like. So yeah, it's hard to tell what people will come up with. I think that the current paradigm of just like changing the data or scaling up or training on slightly different objectives is probably not going to solve all these problems.
I mean, even with the scaling, we see a tendency. I mean, the last 2 years were basically a competition. Who is going to scale up the most and do a 100 trillion parameter language model? And right now, this seems to not be the sole objective of every model to be like the biggest model, but to kind of, yeah.
Right, yeah.
So we do have another question. Tweets in isolation are very difficult to pin down, especially with the speed of culture shift online and more so shift of language use. If any text artifact can be associated with the source, account, user, etc., what help would it be to analyze over text that source has generated and the context, for example, Twitter thread? Is it even possible in principle to do accurate stance evaluation on out-of-context tweets or utterances in general? Thanks.
Yeah, that's an excellent point. I think you're right. I think that this task should be modeled as like with more context, like with more the tweets that the related tweets, like the tweets that if they're replying to someone, the tweets that they replied to, or the replies to that, or this like more elaboration on the specific topic they're discussing, or any kind of context. Because as I mentioned earlier, we asked people to annotate the correctness of the reasoning, and they said for many tweets they just said, I don't know, there's not enough information here. So we used an existing data set, and that's how it was provided. But I do think, yeah, it's if it's hard for people, then yeah, this task is probably not modeled right. So here's another idea for a research direction, to build a new data set for sense detection. Okay, I'll move on to the third part. So this is about real world applications. So we've seen lately a lot of people afraid of large language models because of how good they are. I'm more afraid of the ways in which they're still not good enough, and how what will happen if we deploy them anyway. So for example, if we deploy them in sensitive applications involving people's lives and health. This is not an example for deployment, actually. This is from a couple years ago when GPT-3 was new, and or like 3 years ago, I guess. OpenAI tested it on like a mental health care chatbot. And I mean, it was not deployed. It was just talking to a fake patient, and the fake patient was talking about how they are depressed. And the model suggested or encouraged them to commit suicide. So definitely something we would like to avoid in like for these models to predict something like that. The second risk is regarding personal information, both in terms of what it was already trained on the web, and also, for example, ChatGPT collects the inputs from people, and people do use it for personal things. And there's a lot of lawsuits already happening in different countries around the world about these privacy problems. And then the third example is regarding people's reputation. So this is an example from Australia where this mayor that was involved in like he was a whistleblower on some bribery case, and ChatGPT generated some bio and presented him as being guilty of the bribery. And here's another thought experiment, which is on a related point. So for example, if you had a problem with your ear, would you go to a doctor that read all the medical literature in the world, or would you go to a specialist, an ENT, someone who's specializing in ear, nose, and throat? I would ideally would want to go to an ENT that read all the medical literature in the world, but that probably doesn't exist. You can't read all the medical literature in the world. But among the two, I would prefer the specialist. And similarly, if you're getting divorced, would you go to a person that knows all the laws in all the countries, or to a family lawyer in your specific region? And yeah, I would prefer the second, because you need to know the specific laws in your country and region. Obviously, sometimes it helps knowing laws from other countries, but it could also but you still want someone that specializes in your specific case. And so this is the third example. This is a real world example, not a thought experiment. And this is something that started with so it's a story, something that happened to me. So in December, I took a flight back home to Israel, and the first flight got delayed, so I missed my connection, and I tried to get compensated by the airline, and they claimed it was not within their control. So I found this dedicated Facebook group for air passenger rights in Canada, and I asked them this like a very specific question about my case, and I got a helpful answer from an expert, the one that's running the group. And then I'd follow the advice from the expert, but just for the fun of it, I also asked ChatGPT the same question. And what I got from ChatGPT was surprisingly on topic. It was not, it was referring to actual related topics or relevant ideas, but it was quite different from the expert advice. Like, for example, ChatGPT suggested that I file a claim with CTA, which is something that the expert specifically advised against. So it is definitely an option, but the expert has this extra knowledge of this is not, I don't know, the success rate for that is not as good. And then also ChatGPT suggested to go to small claims court, but this is actually wrong because it missed the information that this is for claims for like a certain amount of money, which mine was not exceeding. And I had to go with a different organization. And then the last part is that the expert also advised me to try to get more information from the airline, because he assumed that the airline would decline to provide this information. And then I can also say, oh, and you see they're infringing they have to provide this information and they're not doing that, and that would work in my favor. And all these nuances that an expert knows were just missed by ChatGPT. And unfortunately, I haven't resolved that case yet, so I can't tell you if the expert advice was helpful. And I also don't have like a control experiment of following advice from ChatGPT. Yeah, I tend to trust an expert on that one. As a result of my question, the group admin that saw that I work on NLP contacted me and told me that they have this website with instructions for every case, like for example, for baggage loss, flight delay, cancellation, etc. But that most people don't actually read it. They just go directly to Facebook, and he has to answer the same questions over and over again. And so now we're collaborating with him on developing this kind of chatbot that doesn't generate like a free text answer, because we don't want to give false legal advice or financial advice, but it will direct users to the most relevant paragraph in the website according to their question. And then that's a project we just started, so I don't have any results or anything. How much time do I have left?
It's all up to you. This time it's just however much time you need. Okay, so I think I'll go over the last part, and then I'll open it for questions about the last two parts. So this one is going to be shorter. So I want to talk about the problem with the way that we test the quality of our models. So one of the common ways that we evaluate NLP models is through multiple choice questions. And the reason we tend to do that is because it's very easy to evaluate them automatically with accuracy. But they have some problems, like, for example, they're very rigid and they don't allow nuances, like in the sense detection example. And they're also artificial, because when we make decisions or make predictions, we don't often get like a list of answer choices to choose from. And models are often right for the wrong reasons, because if you have the incorrect answers, like the distractors, if they're unrelated to, or like less related to the topic, or stylistically different from the correct answers, then maybe the model would just be, excuse me, just recognizing that and then not really performing the actual task. And so in the recent years, there has been a shift to generative tasks, even though we're still testing generative models on multiple choice questions. So generative tasks actually address a lot of these issues. Because the answer is pre-text, then it allows for more nuance. It's more similar to the way that humans reason, and it's far less prone to guessing or finding any kind of spurious correlations, because the answer space is infinite. Unfortunately, for the same reason, it's hard to judge the correctness of a free text answer, and there is currently no reliable automatic evaluation metric. So this is one example task. This is the task of abductive reasoning. And here, the goal is to come up with the most plausible explanation of what happened between two observations. Like, for example, Sarah wanted to make dinner for some guests, and then she had to order pizza for her friends instead. So we can reason about what happened in between. Maybe she didn't know how to cook. So when we test the correctness of model-generated hypothesis, we would like the metric to first reward correct answers that are different from the reference. For example, if the reference is, but she didn't know how to cook, but now we get an alternative explanation that she did cook, but right before the guests arrived, she tasted the food and it tasted bad and she didn't have time to cook something new, so she just had to order pizza instead. This is also a correct answer, but it's completely different from the reference.
On the other hand, we want the model to penalize answers that are incorrect, even if they're very lexically similar to the reference. Like, for example, she didn't know how to cook meat is very similar lexically to she didn't know how to cook, but it's incorrect because she could cook something else. So currently, automatic metrics fall under one of the following categories. The first one is based on lexical overlap, like blue, rouge, meteor, etc. And it doesn't really allow for lexical variation. And it was also shown to have weak correlation with human judgment on various tasks. And so in the example that I showed earlier with the alternative explanation, the overlap is just 1 out of 7 words. So it's a very low score, but this is the correct answer. And then the second approach is based on the similarity of the embeddings of the two texts. Like, for example, with BERT score, you use BERT to embed each one of the references in the generated answers, and then you compare them with cosine similarity. So it does solve the first problem. It does allow for lexical variation, but it might reward incorrect answers that are semantically similar to the references. So in the case of she didn't know how to cook meat, BERT score is 98%, so it's very high. And then there's a new alternative approach recently where people use large language models to evaluate their own, or to evaluate the answers from other models with no human references, which I'm not sure how I feel about it. It sounds incredibly biased to me, but then again, if they actually show that that correlates with human judgment, it might be okay. But I still think humans need to be involved in the process, because if we want to test that something is helpful for humans, so I think we should have humans evaluate that. So my take is that there's still no replacement for human evaluation, but as a note from something I've noticed on the last few projects we've worked on, it's getting increasingly hard to get good quality human evaluation in Mechanical Turk. I think a lot of people are just using language models. There's a lot of bots recently. So it is a problem. It's something that we would have to think of. And then on a related note, the better that large language models get, they achieve human level performance on the artificial benchmarks that we designed for them as the NLP community. And so an alternative is to evaluate them on human benchmarks. Like, for example, GPT-4 was evaluated on benchmarks like the bar exam to become a lawyer in the US. So I think it is a promising approach, but also we need to be a little bit careful about the conclusions that we can draw from test design for people. And so I do think that now that the models are impressively good at understanding and generating text, we need to think about how we test them on downstream tasks that are useful for people. However, I take the specific numbers from the GPT-4 evaluation with a grain of salt, precisely because GPT-4 or like OpenAI didn't disclose any information about the training corpus. And so there are concerns about data contamination. That is that some of the test questions and answers may have been observed during training. And this is an example from Twitter, where in the GPT-4 paper, they show that it performs well on coding questions from like software developer job interviews. But this Twitter user showed that if you ask it questions that were posted on the web before 2021, which is the data cutoff for these models, it gets 100% accuracy. Whereas if you ask it questions that were posted after 2021, it gets 0% accuracy. So that's a very concerning finding. To me, that means that the models didn't learn this skill in a robust way. I'm not saying that they're always just copying verbatim from the training data, but they did not learn a skill in a robust way, and they're overly relying on examples that they have seen during training. So to recap, large language models enable exciting new research directions in NLP, but there are still remaining challenges. And for me, the future directions include reasoning about non-linguistic context, advanced reasoning beyond deductive reasoning. I mentioned diffusible inference here. I also showed an example with deductive reasoning. Counterfactual reasoning is also interesting. And NLP for real-world applications. And of course, evaluation still remains an issue, and we actually need to address that if we want to have a better way to track the progress in the field. So thanks, and I'm happy to answer more questions.
Thank you. This is a really great talk. I think the other people also enjoyed it. If anyone has any questions, you can put it in chat, and if not, I would like to ask some questions. Okay, from a more general perspective, a lot is talked about AI regulation right now, and obviously this is just a personal, it's a question about personal opinion, but what do you think? We hear a lot about it's a philosopher's time to shine and so on. So what do you think is kind of the balance between over-regulating? I mean, AI without any regulation is obviously very dangerous, but over-regulation, especially in the European Union, we're very famous for over-regulating. So how is there a balance kind of between not over-regulating and stifling innovation and still being able to, kind of balance between the two?
Yeah, that's a good question. I mean, the only thing I can say in response to that is that I agree there should be a balance. I think that there should be some regulation because at the moment, what happens in practice is that computer scientists are like determining policy on various aspects of life. And I think there should be a lot more people from diverse backgrounds included in that conversation. And so, yeah, policymakers, like government workers, philosophers, social scientists should be involved. Or like, for example, I don't know, for specific areas like education or the job market, there should be people that specialize in that help make the decisions. Because what happens in practice is like, if like in countries, maybe in Europe, the regulation also happens faster, but in other countries it lags behind, and then these tech companies, they just release products, make it a fact that this thing exists in the world, and when the regulation keeps up with that, it's already widespread. So I do think there should be some regulation, but I agree that it shouldn't be overly regulated, because then you're just throwing the baby out with the bathwater. I think that if you make it so problematic for people to develop any models and deploy any models that use AI, then you're just preventing. You're also preventing the benefits that we can get from that. So I would say there needs to be regulation for sure on any kind of sensitive applications, like in the medical or legal, or the legal domain, or probably other domains, and some, like, I don't know, lighter regulation on other less sensitive areas, and there needs to be some decision on liability, because at the moment, I guess it depends on the country, but just like if you read the terms of service for OpenAI models, they basically remove any liability from themselves for the output of the model. But then I'm assuming right now there's a lot of startups basing on, or like building on top of OpenAI models to provide some outputs to the user in specific topic. And I think there's going to be a lot of lawsuits soon from people being harmed by the outputs of these models. So there definitely needs to be regulation, but I don't have the answer like what should or should not be regulated, but there should be a regulation and there should be balance.
I think it's a good answer to say that the more sensitive topics should be more strictly regulated, but overall it's kind of a dangerous game with innovation.
And also I think we also need to make sure that the regulation is actually helping and not just like making things more complicated. Like, for example, I mean, I don't live in Europe, so I don't really know what other aspects of life it affects. But for example, just recently when I was in Europe for EACL, I used some like I don't know if it was because of the location or I just used some European websites, and like every website I go into asks me to like accept or reject the cookies, and it's like I don't care about it that much. So it seems like I mean, I don't know about the more positive aspects of GDPR, but we want to make sure it's not just someone ticking a box saying yes, we regulated that, and the only thing it does is make people's life more complicated.
Also, it happens. This is a very, I mean, you can spend 5 hours in Europe, and this is the first thing you see, like the craziness of GDPR, especially with the cookies.
Yeah.
And this is kind of a good point that in these cases, sometimes it just becomes, obviously there are positive sides of it, but also in some cases, either it becomes an inconvenience for normal people, and also large companies don't really care that much about fines. So if you are a multi-billion company, getting fined here and there like a few $100 million is breakfast money for them. So they don't really care. So if you overregulate, then startups are going to have a really hard time.
Yeah, that's a really good point. And also the power that the big tech companies have at the moment is actually kind of scary. Like, for example, there was a Senate hearing in the US about the risks of AI, and I thought they gave too much weight to there's inputs from OpenAI, and I mean Sam Altman was in that hearing, and I find there's a conflict of interest because they're profiting from that, and so I don't know. It is problematic right now. There's too much power at the hands of too few companies right now.
I have a semi-related question to that. So 2 months ago, when we had Leonie Weisweiler here, she actually did a talk at Bar Ilan last week, I think, or 2 weeks ago, and we talked about the linguistic aspects of natural language processing, which is also commonly ignored by computer scientists. And we talked about the way large language models understand, or mostly don't actually understand language, because neural networks are obviously inspired from brain architecture, but are not actually working like brains. And the same way, language models are not actually understanding language the way humans do. And she brought a good point, or her argument was that she doesn't think that language models actually need to understand language, which was kind of an interesting point. Yeah,
that's interesting. Yeah, I also think that if let's say that it was performing perfectly on like a human level, like answering questions and interacting with people, then in that case it wouldn't matter that behind the scenes it doesn't actually understand language the way humans do. So I kind of tend to agree with that. But I think that for understanding all kinds of more complicated language, like humor, for example, that you mentioned earlier, I think that yeah, it might not have to be at the level like to understand it like humans do, but yeah, I'm not sure what I'm trying to say here. I think, yeah, I mean, if we were at the point where it can converse with people in a way that it's like they understand language, it doesn't matter if they don't actually understand the language the way that humans do, but I don't think we're there yet.
Also, we're not trying to actually produce a human, and this is a very, when we talk about, you talked about a lot about context in your talk, and this is a good point that, I mean, ChatGPT, for example, I mean, first of all, this is one of hundreds of language models right now. It's very popular right now. So this is one of the few applications which are like more general because everybody can just log in and use it. It's for free.
Yeah.
But most chatbots and language models are used, if they're used in an industry, in a medical, it's all in context. So we don't actually need something that is like super human-like general. Most of the time, it's just fine-tuned on a singular task or a few tasks. So yeah.
Yeah, that's a good point. I think that, I mean, I would like to see maybe like in a few months, if OpenAI will do a survey of how people use ChatGPT and their other models, and like for what tasks and what kind of post-processing they need to do to the outputs of the model, or how much effort it takes to get a high quality answer from the model, or what works, what doesn't. I would really love to see that, because they had this report about the effect on, or the potential effect on the US labor market, which I found interesting, but I also, they were looking at like how exposed each occupation would be based on like automating tasks in that occupation. And I was a bit, I mean, I thought it was a good discussion, but I was also a bit disappointed that they didn't actually ask people about how they use it in their jobs. They just hired annotators and asked them, like show them, okay, this is a particular job, like an animal scientist, and this is the list of tasks that this person does every day. What do you think would be automated, like, or the language models would reduce the task by 50%, like the time taken to perform the task by 50%. And I find that it's very inaccurate. It's really hard to estimate how, like the quality of outputs for a model for a task that you've never actually done. So I do look forward in seeing how people actually use that, and maybe if we have the data for that, we could actually see what kind of other areas we need to work on for these models to be helpful, and maybe what other areas are less important because people are not interested in them.
That's a good point. I not seeing any more questions in chat. If anyone has anything else to say, I would love to ask it to Dr. Shwartz. But if not, I would like to ask our question that we ask every time. If you have any interesting paper recommendation, something you read in the last few days, just it doesn't necessarily have to be connected with this topic, just something you enjoyed reading.
Wow. In the last few days, I've read my students' drafts for the archive deadline. So I unfortunately don't read enough. It's hard to keep up with the literature. Oh, I do have one that I recommend. So this is, let me actually get the link for that. This is a paper about visual metaphors from Tuhin Chakrabarty. Let me find it.
Is it a new paper?
Yeah, I think it's a findings paper at ACL.
Do you remember the author? I think I found...
Yeah, I think oops, no, that's not right.
So... for people currently on YouTube or people that are going to watch the recording, we put all of the papers that we discuss in the description, so you can check it out yourselves. I try to post every paper in the Zoom chat so we can keep up. And
yeah, I
okay.
just posted one.
You posted it, yes.
Yeah.
Thank you. So great. Okay, actually, I don't want to ask just one tiny more question, and I'm not going to keep you anymore. About the kind of perceived gap between academia and the industry, we talk about this with almost everybody we have on. So I would be interested to hear your perspective if you think with the uprise of open source projects and so on, do you think we are going to be able to kind of close this gap, because the industry is very much far ahead and the academia is kind of lagging behind?
So yeah, that's a good question. I don't have a prediction, but I think something will change soon, because it seems like now because of the okay, so I think that the big companies, they were playing like in the same game as the academic groups by like publishing and releasing models and data sets and disclosing all the information, while these models were not useful enough. And now that they're finally useful, so they want to monetize that, and this competitive landscape leads to more closed models and less papers published about them. And also the pace of research makes it so that the big companies now, I don't think they care so much about publishing in conferences. And so I think there's gonna at some point be a disconnect between the kind of work we do in academia versus the kind of, or maybe there is already a disconnect, because I don't think any academic group is currently training large language models. So it seems like this is all the big companies do right now, and then the academic work right now is mostly about analyzing the capabilities of these models. I'm curious to see what would be the effect on how many people work in the field, because the field grew incredibly in the last few years because there were a lot of low-hanging fruit. But now it's kind of different. There's less. To some extent, there are other low-hanging fruit, but I think we're too many people. We're gonna get all of them soon. And then it's going to be maybe more complicated, and maybe some people who are less interested in language per se and were more interested in like solving the machine learning problems might leave the field. So I'm curious to see what would be the effect on the size of the field, and how would conferences look, whether there's going to be a lot of participation and sponsorship and support from big companies or not. I don't have an answer, but I think it might change. Any comments on theory of mind in large language models? So there's an archive paper that I guess I'm allowed to talk about it in a talk. Yeah, we just posted an archive paper. I don't know if you saw that. If you're asking that because, sorry, I'm referring to I don't know if I read the question. Any comments on theory of mind in large language models? And yeah, so I don't know if you're asking that because you saw the archive paper or not, but we talked about how there's a little bit of it probably, but it's not completely robust. And the prior work that claimed that language models have theory of mind was not really doing proper like rigorous experiments to show that. So yeah, I recommend looking at the archive paper. I can post it here.
Yeah, thank you for your response. I just wanted to get on to talk to clarify that, because I have the same viewpoint. And if you could link to that archive paper, that'd be great, because I think the initial wave of work trying to probe theory of mind and LLMs was like really overblown and not rigorous at all and totally unscientific. So
yeah, thanks for saying that. I'm glad to hear other people thinking that.
Yeah, cool. Thank you.
I also so okay, I'm going to also post this paper. I'm seeing a lot of thank yous in the chat. I would like to say thank you also. Thanks for taking 1 hour, 20 minutes of your life to talk to us. It was very interesting, really cool talk. And yeah, thanks everybody for participating. We are going to upload this on YouTube if this is okay with you, on our channel.
Yeah, and thank you very much for having me. I really enjoyed the discussion.
Thank you so much.
Thank you.
Thanks.
Bye.
Bye. Thanks.